Good evening, everyone. Today's session will be handled by Dr. Digvijay Pawar, sir, who is already in the meeting. And not to tell you about the new, sir has given an excellent presentation yesterday, and we are very delighted and happy to have you, sir. Thank you for joining us, and thank you for giving your time for presenting your session. Now I welcome Dr. Digvijay S. Pawar, sir, to give his presentation. And I request all participants, please come and welcome our today's resource person. Thank you. Over to you, sir. Mm.
Hello, everyone. Can you please confirm if I'm audible?
Yes, sir, you're audible, sir. Loud and clear.
Oh, great. Thank you. Thank you. And all of you, apologies from my side. I was just involved in some important meeting and unfortunately could not get out of it. So thank you so much for your patience and let's continue where we left yesterday. So once again, good evening, everyone. And I'm sharing my screen. May I know if the screen is visible and you're able to see?
Yes, sir. The screen is visible, sir.
Perfect, perfect. Thank you, thank you.
Okay, sir. Thank you.
So, great. I think all of you. I'll slightly continue because I have lost 10 minutes, so I will definitely utilize those 10 minutes again. Yesterday we talked about autonomous vehicles. We talked about how IIT Hyderabad is actually working on developing this technology. I actually did not present the interesting research that we are doing because this is not a research presentation. But let me just tell you that I have already graduated 5 PhD students, and currently 7 PhD students are working with me, of which 3 of them are actually working on ADAS systems, which is nothing but Advanced Driver Assistance System. Basically, when you talk about level 1 and level 2, that's where the ADAS systems come into picture, um, which is an assistance system for the driver. Okay, so you might have heard about XUV 700 or newly launched Amaze, or you talk about Honda's any mostly all high-end vehicles will have ADAS features, and it usually it's a vision based. It relies on a vision based sensing technology. What I mean is there are cameras which are fixed at on the windshield, on the top of the windshield, and the camera actually detects the, it's like an eye which detects the lane markings, detects the object in front, does all those calculations. There are certain algorithms that are being created which help them to give warning to the drivers in advance. So that is more about ADAS systems, and these are already existing. Okay, unfortunately, people use it wisely or unwisely. I would say that way. You might have seen certain videos which were surfacing when XUV 700 was launched. People kept the vehicle on ADAS mode. Okay, with the lane assist system on, adaptive cruise control on, and then and they're moving around inside the car. So these kind of systems are not meant for those things, right? Which people are trying to showcase. It is more of an assistance to the driver if something goes wrong, if the driver is not able to notice in advance. Okay, the sensors would notice these things and actually inform the drivers about possible collision or possible hazard that they might come across. Okay, so that was more about the technologies within the vehicle, and I talked about passive safety measures and active safety measures. So passive safety, I mean, both the measures, are very important. from the user's safety perspective, especially the passive safety functions come into picture when crash happens, right? Whenever there is a crash, okay, what happens is like the seat belts will help you to avoid the injury. The airbags will avoid or try to minimize the injury that you're going through. And moreover, these active safety measures are something which actually work actively. It means just before the accident or a crash is about to happen, these active safety systems will alert the drivers or try to take certain decisions which possibly would avoid the crash itself. Okay, so that was all about the vehicle technologies that we discussed about. We discussed about the history related to adoption of technology, be it the cell phone, be it the washing machines, the dishwashers. You see how exactly uh, this kind of entities are adopted by households in US. Of course, we don't have this data in Indian context, but it's quite interesting to understand the penetration rate of technology, and that's what actually makes us realize that yes, the technology is important and people opt for it. It's just a matter of time. Okay, so now having said we've said all these things, today I'm going to talk about the trends in infrastructure and operating technologies. Okay, so before I move on, like, I just want to tell you all about what is intelligent transportation systems, right? So basically, it is it is more to do with integration of technologies. Uh, it is more to do with the communication technologies, or let's say computer science, electrical engineering or electronic engineering, and civil engineering coming together, working in sync to help drivers, to help the users to move from one place to another place more efficiently and safely. Okay, so this ITS, if you look at the users of the ITS systems, uh, it is all public which is traveling or using the system. So even the traffic managers, even the system operators who are sitting into a traffic control room, they are also the users of ITS system. So what are the main objectives? So if you look at the transportation system, uh, the intention is to increase the efficiency of the system. So basically, when we talk about transportation systems engineering, we talk about two major aspects, that is mobility and accessibility, right? So mobility is all about how fast you can move on a given system, and accessibility is how easily you are able to access, okay, different locations within the given system, right? So, when you talk about expressways, when you talk about freeways, okay, the mobility is quite high because you're able to move fast, right? These are all access controlled highways where you cannot access from any location that you desire to. Okay, there are certain locations from where you can actually get onto expressways or get out of expressways or freeways, right? So these are called as access controlled because the access is controlled. And on these access controlled highways, the speeds are quite high. That means you're able to move quite fastly from one location to another location. Whereas if you talk about collector streets, you talk about local streets, you can't move fast. Look at the speed limits that we generally post: 20 kilometer per hour, 30 kilometer per hour. The intention there is accessibility, right? You should be able to access the neighboring or the neighborhood over there. So more the mobility, less is the accessibility. More is the accessibility, less is the mobility. This is something which all of us we need to understand first. Okay, and each of this, like mobility and accessibility, has its own roles to play for a type of system that we are talking about, and the IT systems which are required for this type of highways, or let's say this type of systems, what I mean is expressways and freeways versus local streets or the arterials. Even arterials, you see, These are major streets where the traffic is seen at higher speeds. However, there will be certain interrupted flow conditions that are observed. So there, the requirement of ITS would be altogether different as compared to the ITS on expressways, and which I'll talk about some examples. Okay. So, the main objective is all about incident management. What it means is like how quickly you can take care of any crash which is being observed, right? So, here the intent is to save the life. Okay, how you take care of traffic during the disaster, how do you try to minimize the impact of crashes or any disaster that happens or any incident that happens, right? So incident can be anything. It can be even a tree falling on a road. How quickly you're reacting to the situation, that is what matters. Okay, then improved safety, of course, our intention is to design the system which is safe. Okay, so I think some of you might have heard about safe system approach, right? So safe system approach is something which talks about um, uh, uh, drivers or the road users should not be punished for their mistake. I mean, they should not be punished to death, okay, or serious injuries. So being a driver, okay, we all are human beings, we are bound to make mistakes, right? Even if you are on the road, you're bound to make mistake, okay, and that mistake can be because of various reasons. However, even if I make a mistake on a road, that road or that infrastructure should not punish me to death. Okay, it should not be a fatal crash, right? So then how can I design a system? Even if I make a mistake, even if my vehicle goes onto a curb, or even if it goes onto a footpath, nobody's hurt. Can I design such type of system? Yes, it's possible. That is called as forgiving systems. Okay, so where we talk about safe roads, we talk about safe users, we talk about safe speed, we talk about the incident management system, right? So that is all about safe system approach. So the main objective is you should not punish the user in a way that somebody comes across a death or serious injury. Okay, then, of course, we talk about reduced environmental impact. Okay, we talk about enforcement. We talk about road user charging. I'm going to talk about this enforcement in detail, how exactly the enforcement is done, and so on. Okay, so these are some classic examples of ITS, like for example, advanced traffic management system, traveler information system, vehicle control system, toll collection systems. In general, we term it as advanced transportation systems, and so on. So the overall picture, if you look at the uh, ITS as such, the context is you monitor the traffic, okay, whatever way you can, you assess the system, and you act on it. Okay. So now the monitoring of the system can be done in several ways. Okay, it can be based upon sensors that are deployed on the road. It can be based on the cameras that are deployed on the road. It can be based on manually, like for example, traffic police standing itself. He or she is standing itself at a junction and trying to monitor the traffic is one way of monitoring the traffic, right? All of you, but it's not an effective way of monitoring the traffic. How can I see the whole system? How can I have an overall picture of the system? In a way that it helps me to understand the bottlenecks, the understand where exactly the traffic jams are happening, and so on, right? So that's the reason why you see all the smart cities and all deployed with a lot of cameras just to understand where exactly the traffic jam has happened, why it has happened. Can I provide, quick access to the location to resolve the issue and so on. So basically, you're monitoring the system, you're assessing what has happened, and then you're acting on it. Getting my point of view? It's monitoring, assessing, and acting. Now, the first figure that I'm showing here, okay, the topmost one, okay, let me use the pen. All of you can see here. This is the actual photograph, okay, that I have taken in Tokyo. So when I visited Japan, I had an opportunity to visit their control room. So this is the control room actually, and I'm standing over here. I'm not sure whether I'm visible to you, but I can show you in the next picture. Okay. So this is the whole. So this is our team from IIT Hyderabad, which visited Tokyo, and then we witnessed how exactly the system has been managed. It's very interesting, all of you. If you see um, even if you just go on Google Maps, you will see certain links red in color, certain links, blue in color, orange in color, yellow in color, and so on. Similarly, this map also is showing you different colors over here. Okay, but the interesting fact that I observed was, if you click on this one link, okay, the video camera corresponding to that link will actually will be switched on. Very interesting, right, all of you? So you just click on it and on the link, and then the video camera gets on, and then you get to know why exactly there is a jam. Okay, so not only that, so this specific system was not only designed for the roadways, it was even designed for electricity supply, it was designed for water supply. So that means everything was absolutely well managed. Any loopholes, any issues in the system, the triggers are generated, and you get to know all the issues in advance. Okay, so this I have clicked in the month of January in 2018. Then um, you have this. Okay, let me show it the cursor. Ahmedabad has an excellent traffic control room. Okay. Again, I forgot to mention a date over here, but this was pre-COVID again in 20, uh, just the beginning of 2020. Okay, late 2019 possibly, where we visited the Ahmedabad's traffic control room, and we observed how exactly the whole traffic management is done. Okay, even the generation of the challan is automatic. Okay, it's fully automatic. The intervention from the traffic police is very less. This is the one which we have in Cyberabad, okay, in Telangana, in Hyderabad, okay, and again, the Cyberabad zone, they generate all these challans, okay. Of course, there's a small manual intervention where they confirm the vehicle type and whether the um, a specific uh, a rule has been violated by the user is actually noted uh, by the traffic police, and then the challan is generated. And then you have this Telangana State Police Integrated Command and Control Center. It's a beautiful facility that has been developed. You can see this facility, all of you. I have visited this facility as well, and we observed that, okay, the way the things are managed, absolutely great, right? So you have data related to events that are happening all within the Hyderabad. Uh, uh, what kind of precaution needs to be taken care of? There is a vigilance. I mean, people observe things happening on the roads. The information is given to the traffic police then and there itself, and the issues are resolved. So this is one classic example, of ITS where actually you generate the challans automatically. Okay. So for example, just to talk about this specific violation by the user. Okay. So if you see the pillion rider is not wearing the helmet, and this specific use case, or let's say the challenge generation is for not wearing the helmet by the pillion rider, okay, which is clearly written over here. I hope it is visible for you, but I can see that not wearing helmet by pillion rider, and then you see this number TS08. The same number is over here. They confirm which vehicle type it is. Okay, so once the vehicle type is confirmed, then they generate the challan. Okay, and of course you receive challans on your phone if your mobile phone is registered with the same number when you are actually buying the vehicle and so on. However, yeah, I mean, there are incidences where the manual challans are also being generated and sent to the people. Here you can see it is for triple riding. You see there are three people. Okay, so and then the total pending challans are three, and total amount the user has to pay is 1470, right? And if you see, actually they have sent this letter. Okay, this is the inland letter card. However, this letter has come back. I've just taken a snapshot of it saying that insufficient address returned to sender. Okay, so that's the reason why the letter has come back to the police. So these are the practical issues, I mean, what the police is going through. Okay, when people do not respond, because there are people who rent the facility or rent the home and then move from one location to another location and so on. So yeah, I think it's interesting to understand. Okay, how exactly things are being done. I have observed this on my own. Now, coming towards the ITS, when you talk about intelligent transport system, these are all part of ITS systems. But if you look at the way the IT system is being designed, okay, we talk about concept of operation, we talk about high level design, we talk about detailed design, we talk about installation and configuration, and then we talk about operation. But please understand, it does not stop at operation. The moment you start operating the IT systems that you have installed, you will realize that there are certain flaws, there are certain improvements that need to be done, because the user's acceptance towards the system versus the user's behavior towards the system needs to be understood. Okay, so you just deploy an IT system, but nobody respecting it. Wait, it doesn't make any sense, right? Or the user is not behaving as per the expected behavior by the designers, then also it is not useful. That means once you put something in operation, you have to go back, try to understand how well the system is operating. If it is not operating with the efficiency that you are looking at, okay, you are looking at, then again go back to the detailed design, installation, and configuration, and look at the operation. Okay, so that's the iterating process. Okay, where we try to understand the behavioral changes, try to understand the compliance of the people towards the systems that are being developed. So today, I'll slightly focus on the highway ITS system. Okay, um, so it is more to do with highway intelligent transportation systems. Okay, so these two images that I have shown over here. Okay, one of them is more of a graphical type, and the other one is the actual photograph. Okay, I'm going to explain them in detail. So why do we need intelligent highways? So obviously, the topmost reason would be to reduce the number of crashes, right, all of you? Then can I detect these problems automatically? Okay, because once the crash happens on the roadway, is anybody aware? Let's say if something goes wrong on a highway, let's say on a national highway, uh, what needs to be done? Any idea? Let's say, God forbid, it should not happen. God forbid, it should not happen. But let's say some crash happens, and any one of is involved in it. Okay, I hope nothing goes wrong. But then, what is the step that you take? Whom do you call? Do you know the emergency number? Anybody has idea over here? You can actually text, or you can just unmute yourself, and you can talk about it. I mean, it has to be a discussion section. It's very important, all of you. So do you have any idea that um, how to get in touch with the emergency care system? Any idea anyone has on national highways? Emergency number you're aware of? See, we have so many numbers, but possibly some of us are not aware of the emergency number. So emergency number is 1033. It is 1033. So if something goes wrong, okay, you should call number called as 103. Quite often you might be on national highways. I'm talking about national highways. Okay, you talk about 1033. If you call, that number rings to Delhi. Okay, and from Delhi they will connect you with the local incident management system. Okay, so there are people, okay, who are being deployed on a particular stretch with certain facilities, which includes ambulance, crane, emergency aid, which will come as soon as possible and try to facilitate you the needed emergency care. It's very important that you contact 1033 and get the emergency services, because that specific, if somebody is injured, that golden hour, okay, that first 1 hour, if somebody is actually injured, is very, very important. So you should not be lost, right? What to do, whom to contact? You cannot contact that time your own family members. Of course, you will contact, but how do we contact somebody who can actually help you at that point of time? So very important, all of you. If you have your phone right now with you, save this number 1033 as an emergency highway, call or something like that, and then the system will help you. Okay, but it's a long process. I'm not going to talk about incident management system. Okay, I'm actually working on this project called as incident management system, where if something goes wrong on a highway, how quickly they are able to respond. So yes, That is one thing which is very important. Even something happens, okay, how quickly you can respond to the situation. Making travel efficient and faster, energy saving, okay. Avoid problem either slowing down or taking another route. This is also very important, right? All of you. Let's say there is some incident which has happened on a road, okay, and it's completely jammed, and there's an alternative route to reach to your destination. But how do I get to know that some incident has happened and that is delaying your whole journey? Yes, that's possible if my system actually is connected with the infrastructure and with the users or the managers of the system. They can inform me based on the overhead VMS, variable message signs that are being placed. So classic example, let's see, look at this. It says hard shoulder for this exit only. That means this is a hard shoulder. Okay, this is a hard shoulder or a paved shoulder, which can be used actually. You can use this. Usually, the shoulders should not be used. Shoulders are actually meant for emergency purpose. If your vehicle is at some fault, you can stop your vehicle over there, or where emergency overtake and so on. But here they're exclusively mentioning that yes, you can use the hard shoulder. Go ahead, you can use the hard shoulder, but only for this exit. Okay, this specific VMS says accident ahead, reduce speed, exit 230 closed. Now, when we have such kind of information in advance, this helps people to plan, right, Rafi? So that is the beauty of advanced transportation system. So this is like then we have variable speed signboards. Okay, this is actual photo which I have clicked in Melbourne again in 2019 in month of February. So you can see these are the actually signboards, okay, and right now there is a uniform speed that is being displayed on different lanes, okay, 80, 80, 80, which implies that okay, you need to maintain those speeds. Okay, however, the speeds can actually vary. You can change the speeds based on the lane that you are targeting. Okay, so the speed limit changes according to the current environmental and the road conditions and is displayed on an electronic traffic sign. Okay, and document about and this is kind of like documented in a concept document, right? So here, let's say sometimes early mornings when there's a foggy situation, you can actually put speed limit of 40. It's a variable message. Okay? So usually it indicates a maximum speed and may also list the minimum speed also, that this is the minimum speed that you want to maintain. So the concept of minimum speed is very important, right, all of you? Why am I saying this is especially on expressways, that's the reason why you don't see a lot of mix of vehicles on expressways or freeways. What I intend to say, we don't allow two-wheelers, we don't allow auto rickshaws on expressways. What is the reason? Because they are flying at lower speeds. Now, when you have a mix of vehicles with really high speed and low speed, the speed differentials are quite high. And the moment you see a high speed differential, there are high chances that crashes may happen. Right, all of you? It's very important. Okay. Um, that's the reason when even I tell people that you have to respect the speeds, you have to even maintain the minimum speed also. You cannot, just because you want to talk on the phone, you cannot just drive on the left side and drive at 30 kilometer per hour and just bother others, right? Or if you're 40 kilometer per hour, if this posted speed limit is 80 kilometer per hour. So quite often we make mistake that we feel that, okay, no, I'm on the left side and I'm talking on the phone and that's the reason why I'm traveling at 30, 40. No, it's going to pose danger to other road users. That's the reason why we always recommend you completely stop. You go out of the lane, stop your vehicle on the shoulder, and then you speak on the phone. There are some road users who speak on the phone and try to maintain the rightmost lane. They think that okay, I'm not bothering others. No, no, no. Rightmost lane is meant for overtaking. That you cannot use it for driving quite often. Even I have to tell people, quite often I tell a lot of drivers that the rightmost lane is only for overtaking. You sometimes misunderstand that okay, if I'm driving fast, I will use only right lane. No, you're not supposed to. As soon as you overtake, you come to the left lane again, okay, the second lane. The reason being is, on the rightmost lane, if it's a divided road, you always see a curb or let's say a divider or a median. And generally at high speeds, um, sometimes if your vehicle tires, are not well maintained, the pressure is not well maintained, it might burst. And imagine if the vehicle tire bursts, okay, at that high speed, will you be able to control your vehicle? No, you can't. So the vehicle is going to hit the curb, okay, and then you know what may happen. You know, you might go on to the other side. Your vehicle might topple or overturn, I would say. So you need some safety margin. You need some margin for yourself to control the vehicle. That's the reason why you have to take back your vehicle on the second lane, okay, when you're driving, especially on expressways. And rightmost lane has to be exclusively used only for overtaking. So don't subject yourself to high risk on expressways. Similarly, I always tell people that do not drive along with the trucks. Okay, you just simply quickly overtake, complete the maneuver, come to the target lane, and just move on. Okay, so because you want to avoid exposure, okay, maximum exposure to risk, you should avoid that. Okay, well, that was more about safety, and sorry to divert, but I feel that's very important for us to understand. This is another photograph, very interesting information to the users about where exactly is the left lane. For Science Works Museum, you take a left lane only. There is a information for speeds that has been given. Then this is a VMS, variable message sign, which displays information about the tunnel closure. Okay, that too on Sunday. Okay? 10th February from 10 p.m. to 5 a.m. Quite interesting information, right? All of you. So on the same day, they are mentioning that, okay, there will be a tunnel closure. So you are giving information to the users in advance, and your intention here is that the drivers, the users of the road, should not be, um, subjected to unnecessary chaos, okay, or else there'll be long queue and people are not aware of. So you just simply inform them in advance that this will be happening. So when you talk about concept of operation, here the intent is to determine the key factors that are important for operation of the corridor. Okay, so it's more of forming a view on how ITS can help managing the key factors. Document about concept of operation in the document. Okay, so the actual thinking and design process takes place in creating the high level design from the concept of operation. And the designs typically need to adhere to an appropriate national or international standard. That is very important. Okay. So currently, we are also working on developing, there are some standards, of course. Then again, the ITS forum is working. I'm also part of it. We are working on developing, some national and international standards. Okay. For Indian conditions. So this is one classical example of Mumbai Pune Expressway. It's India's first access control high speed corridor. Okay, which is 6-lane divided highway with paved shoulder on both the sides, close to 100 kilometer long, 17 kilometer in mountainous section. Okay, around 6 kilometers of 4-lane tunnels. So operational challenges are overspeeding or speeding in general, I would say, high traffic volumes. Okay, high percentage of heavy vehicles, speed at steep gradient. Now, these are the actual challenges that are being observed. Now, how do we take care of these challenges? There is where the concept of operation comes into picture. Okay, so ensuring safety despite rain and fog during 4 months of monsoon rains, safety within the tunnels. These are all the issues that are being highlighted, right? Now, this specific slides actually talks about operational challenges. So, for example, a lot of people, especially in monsoon, they stop just in the ghat sections. Okay, and they want to witness the waterfalls, they want to take photographs and so on. So look at this classic example here, all of you. There is a board over here which is clearly stating that please do not stop here. Okay, it's very important, do not stop here. Despite of that, you see that people are actually stopping their vehicles and taking the photographs. Now, there have been incidences where, people suddenly start overtaking from the left. Just imagine there are lead, trucks ahead of you, okay, and they are queued over here, and you realize that there is a left lane which is empty when you're slightly behind. You suddenly come onto the left side and you realize there's a vehicle which is stopped. Now you're moving at 60, 70. Do you think the stopping distance that is available for you is enough to stop safely. No, you will just kill these people, right? That is what has been happening. Now, this is the actual reality. But even we put the boards, people are actually stopping. Okay. So if you look at the statistics, I mean, till April 2018, total 105 accidents were observed. Okay, 102 people injured. In 2017, 99 people were killed, 375 people were injured. Look at the statistics. How many people are actually involved in crashes? Now the police launched a special drive, no halting, no parking. Okay, on expressway. Then breakdown vehicles generally halt on the service lane where such accidents have occurred. This is also very important, all of you. Even on the service lane, if your breakdown vehicle is actually kept, people, because of the low speed, I mean, especially the trucks, heavily loaded trucks, being a steep slope, they ply at really low speeds. Okay, and then suddenly a car which is able to ply at 80 km per hour on a steep gradient tries to overtake from the left and realizes there is a halted vehicle. It is crashing onto it. So people should stay away from the breakdown vehicles. Very important. Okay, so is there any mechanism in which actually we can develop a system? Yes, it's possible. Why not we fix some kind of incident detection cameras? Okay, incident IDC or IID cameras. These cameras will detect any vehicle that is actually being parked over here. Okay, and give a real-time warning. There can be speakers, and those speakers will actually say that, okay, you are being observed and try to move your vehicle as soon as possible. Even the photographs of the number plates can be taken, and warning and the challans can be issued because you're strictly saying that no stopping here. Okay, so usually you might have seen the no stopping sign, right? All of you, usually blue, and then the red cross is present over there. These are something really important things, okay, that needs to be addressed. So these are the recommended ITS subsystems like traffic detection and monitoring system. Okay, so we should monitor the flow of the traffic, vehicle counting should be done, tunnel safety, incident detection, construction liability, animal warning, very important because such if you have not only animal warning, in fact, I'll give you a classic example here. Even if suppose there is a possibility of boulders actually falling, can I get warning in advance? Yes, it's possible. If I can place the sensors on the hilly regions, which are generally uh, realized to be, slightly weak in nature, and there are chances that they may fall, the boulders may fall on the road. Can I place those sensors and try to understand whether there are chances of this kind of incidents happening? So the warning can be given in advance to the management people, and then you can avoid this kind of situation. Then you can have this SOS, save our ship or save our soul. Okay, it's an emergency box, call box, where you just simply dial the number. Okay, even if you use this number again, as I said, it goes to 1033, and from there they connect with the local incident management system, the meteorological system, where you're able to predict, sometimes there are sudden rains. Can I predict in advance and give warning to the driver? Possible. And then there are systems which are actually like, way in motion. So I don't have to actually stop my vehicle. Okay, wait and create, not challan, but of course what we call it as the uh, challan for weighing. Yes, challan for weighing they call it as. So um, because overweight vehicles will be issued a challan. You have to pay in a prescribed or legal limits. So, can I do weighing on go? Yes, it's possible. So high speed weighing motion is possible, where you can save times of truck drivers and so on. So if you look, you
Excuse me, sir. You are on the mute actually.
I just got muted, or it was muted before?
Sir,
Let me.
just got muted, sir.
Oh, thank you. Thank you. Should I go to the previous slide?
Yes, sir.
They were able to hear about this system, like AID should detect the wrong.
Yes, sir. They were here about this system, sir. Just the introduction of, yes, sir. This slide was there.
Okay, thank you. Thank you so much. Yeah. So, especially on expressways, sudden lane closure is not a great idea. You need to give information to the users in advance, and that's the reason why you place this kind of overhead gantry, and over that gantry you have this information stating that which particular lane is closed, this lane is closed, this lane is closed. You use this lane.
Excuse me, sir. Sir, again it got muted, sir. Sorry for the inconvenience.
Yeah, now I'm able to.
Oh,
So,
yes, yes.
so I think it's happening from the other side because I'm not touching the screen. Could you
Okay,
please
sir.
look into it? Yeah.
Yes, yes, sir. We'll check with the team, sir.
Okay. Thank you so much.
Thank you, sir.
Okay. So my screen is visible now.
Yes, sir. Is it visible, sir?
Yeah. Thank you. Yes. So I was talking about the lane closure. The smart system which will actually help road users to understand the lane closure beforehand. I was talking about hazard lights, right, all of you. So quite often we use hazard lights during the fog, and we think that our visibility is high, or other people are able to see. But please understand, in order to differentiate the vehicle which is broke down and the vehicle which is moving, we use hazard lights. So hazard lights are only meant to be kept or to be on only when your vehicle is in breakdown condition, not when it is moving actually, right? So that time you should just switch on the fog lights, okay, the red light behind the tail red lights, okay, they are good enough to warn the drivers or inform the drivers behind you, especially the following vehicles, about the lead vehicle, presence of lead vehicle, okay. This specific, if you look at uh, the overhead VMS system is displaying accident ahead, 30 minutes delay, use next off ramp. So if somebody is telling me that there's already a crash ahead, then I don't need to commute at 100 or 120 kmph on expressways. I can go with the minimum speed which is prescribed, let's say 80 kilometer per hour, so that I can save that fuel also, right? When you travel at higher speeds, the fuel consumption is high, okay, more emissions. So rather I'll drive quite efficiently. Here also is a hard shoulder for this exit only. So this we have seen previously. Then there are systems, very interesting systems, such as the average speed cameras, right? Which actually uh, is a system which is quite effective as well. You two cameras at two different locations. You know the distance between these two locations, okay, and based upon the time taken by the vehicle to cross point A and point B, you just simply find out the speeds. Because what happens is with the fixed base system, like for example, if there's only one camera which is detecting the speeds, or let's say one sensor which is detecting speed at a particular location, people over the time they learn, that where exactly the camera is being placed, and only at that location they will reduce the speeds, right? But that is not more effective, right, all of you? Because people understand, people learn where the location is, and then adopt according to that they adopt themselves. So how can I avoid that? So maybe I'll just measure the average speed between the two locations and then issue the challan to the users. Then there are, of course, downhill truck speed advisory systems, especially trucks which are heavily loaded. Um, they cannot stop. The brakes fail because it gets heated up when they continuously apply brakes. It gets heated up and the brake efficiency reduces. So this specific system is giving warning to the trucks that your speed is 64, slow down. Okay, it's telling you in advance that you need to slow down or else you won't be able to control your vehicle. This is the IT subsystem for tunnel safety. Okay, so especially things may go wrong inside the tunnel, and if something goes wrong, how quickly I can give information to the users. So you can fix PTZ cameras, lane control signs, fire alarm systems, emergency call box every 100 meter within the tunnel. Okay, thermography based AID cameras every 15 meters, so as to answer, so as to understand if any incident happens. You can detect and send it. So these are the other highway IT's components. For example, RAM metering. I think I'm not sure how many of you have heard it, but right now in India we are talking about expressways and freeways. But our expressways and freeways are not fully jam. Okay, but in next 10 years you will see a lot of traffic on expressways. Now, when you see really heavy traffic on expressways, okay, you need to meter the ramps. What it means is you need to govern the rate at which the vehicles are entering onto a freeway segment, okay, or a expressway. So what we do is we try to measure the gap between the vehicles on the extreme right lane in this case, okay. Whenever you see the safe gap between the two vehicles, I mean the enough gap, you actually allow these vehicles on the ramp to proceed. So at a certain speed only you can actually merge. If you merge at lower speeds, it will create a shock wave, and that is what you don't want, right? So how exactly it looks like, for example, just let me show you this. So it clearly shows here, all of you. There's a RAM meter when flashing. Okay, prepare to stop. You are giving a warning in advance. Okay, and once the vehicle actually approaches the signal, so it's a normal signaling system. Okay, however, the operations are quite quick. That means as soon as you get a green light, here you can see the green. Okay, as soon as you get a green, you go. Red, you stop. Green, you go. Okay, now green will come. Okay, and then vehicle move ahead. Only one vehicle at a time. So it's just one vehicle at a time. Okay, but when there are multiple lanes on the ramp, okay, then you allow those multiple vehicles also to proceed accordingly. Even the acceleration lanes are actually managed. Then overhead detection system in India, you could see, there are always those horizontal bars which are actually placed on the top, metal bars, so that the heavy vehicle gets stuck at that location, or especially overheight vehicles get stuck over there and it does not damage the property ahead. For example, there is a bridge ahead, okay, it should not get stuck over there, it should not damage, it's a costly affair, right? And you're giving warning in advance. So one such active traffic management system. In fact, I have witnessed this system when I was in UK last year, where I'll just directly go to the system, okay, because we have the last 5 minutes. So in this active traffic management system, this is the actual system that they have developed. I'll just explain you what all it actually involves. So it has a telephone emergency call service, which nowadays every highway has. It has an emergency refuge area where something goes wrong with your vehicle, you can stop in the refuge area. It has that camera to detect the vehicle in emergency refuge area. So the camera detects it and gives warning, give information to the person who is sitting in a control room. Okay, there's a VMS, you can see this. Okay, VMS for driver information, signs to inform the speed limit. Okay, there are cameras for speed enforcement, there are loops to monitor the speeds and traffic flow, there are hard shoulders, which can be used during the emergency and so on. So these are all systems which are actually existing on this specific segment of a highway, which is M42. Okay, this is a smart highway in Korea. Okay, which talks about variable message signs, vehicle detectors, traffic signal control, CCTV cameras. Nowadays, these are all existing, on Indian roads also. It's all about the efficiency of the system, how well the system is working. Quite often, you see these systems are always under maintenance. Okay. This is Agra Greater Noida, Yamuna Expressway. It is 6-lane divided highway. Recorded 626 deaths, and 4842 accidents till June 30, 2017. And the major issue was the fog. If you could see, early morning people are traveling at really high speeds. Some of you might have actually come across, this video where people are actually bombarding onto the vehicles, right? So see how they are requesting vehicles to come out quickly. So this is how, So can I give a warning to the users as soon as possible? Right? Yes, it's possible. These are the IT systems which are already, put on the Yamuna Expressway. Surveillance camera at every 5 kilometers, video incident detection system, speed monitoring system, variable messaging, meteorological systems, and so on. Of course, there are several challenges in Indian context. Okay, we have underdeveloped road network, severe budget restrictions, explosive urbanization and growth, lack of resources, less demand for automation, lack of interest, lack of user awareness, and so on. So this is all about, the development. But I remember we had exclusively one specific question about autonomous vehicles in the previous, lecture of mine, where let me talk about, you know, the challenges with respect to autonomous vehicles. So I have 5 minutes, right, Dr. Ganesh?
Yes, sir. Yes, sir. You have 5 minutes.
Thank you so much. Yeah, I started a bit late, so I think I'll use that time. Let me just open the PPT. Okay, just give me 1 minute. So we were talking about because the question was more about, the different risks which are associated with the autonomous vehicles, right, all of you? So basically, the major concerns with respect to AVs is all about the safety, okay? Then the liability issue, who is responsible, insurance, and so on. The privacy issues, okay, I can hack the information, I can get your data. Cybersecurity is another concern. And then it is all about industry influence, what industry is actually seeking for. So when we did a lot of research, we understand, when it comes to safety regulations, all these countries have stated their own, white paper. They have come up with guidelines, while especially for testing the autonomous vehicles. When it comes to the liability, and especially when coming towards the insurance responsibility, these are the responsible people in US. It is state government, UK insurance company, Singapore human driver, Australia compulsory third party, China no response strategy, Japan manufacturers, and so on. Now this is little old data, but now this has been improving. Then there's a these are the privacy and cybersecurity related uh, data. When it comes to the infrastructure, these are the details about what kind of infrastructure that can be expected. Okay. We already discussed about SAE levels, okay, for different types of autonomy, and then um, mandatory testings for ADAS testings, especially collision avoidance testing, lane departure warning, blind spot detection testing, GPS testing, what kind of testing needs to be done, and so on. These are different testing methods: software in testing, simulation testing, X in loop simulation testing, driving test in real traffic, and so on. So we are actually doing, whenever you develop a test track, I mean, which I talked about, the intention is all about, type of testing that you want to do. You want to do accelerated evaluation. You want to do behavioral competence. You want to check the corner cases. That means you want to push the limit and, do highly advanced limits of the highly advanced automated vehicles and so on. Okay. And then some mandatory AV sensing systems that we have actually suggested. So these things I will not present, which is more about the regulations that I have designed for autonomous vehicles. Okay, the kind of uh, regulations or the testing they should go on. I visited a Michigan test bed in the Michigan University of Michigan. Okay, tree, and I've seen the test bed facility over there. Okay, so basically at IIT Hyderabad, we have been working on several research domains. One is to do with the simulator, virtual reality, and assisted driving data, and so on. However, it all has its challenges, especially when it comes to autonomous vehicle in Indian context. You see how exactly the challenges are being observed. Okay. Now, to answer one specific question, which was related to the ethical dilemma, yes. I mean, um, please understand, there have been incidences where, even to save a dog, the driver has steered the vehicle suddenly and has killed all the occupants within the car itself, right? So there would be high chances that the vehicle would be in a good position than human beings to take the decisions instantly, right? So sometimes there's something called as overcompensation. What it means is, let's say your vehicle steers away from the highway, and you suddenly notice that you suddenly oversteer your vehicle. So when you suddenly what I mean is overcompensate, the vehicle goes onto the other side. So possibly these kind of things can be avoided. But yes, if you have to kick between, if there's ethical dilemma is to do with, killing one old lady versus, a baby, uh, uh, crossing a road. Uh, uh, this is something really difficult to, answer at this stage. There are a lot of theories that are being worked on. You go through the research, you'll understand how exactly the decision would be made. But quite often humans, we are quite this instantly whatever we decide um, is controlled by the machine. So please understand, if you apply brakes suddenly at high speeds, let's say 100 kilometer per hour, but if your tires are not in good condition, you do not have emergency brake systems, or you do not have, let's say, electronic brake assist system, or system itself, that's a vehicle which is of huge power. It's not in your control. So how machine behaves, if the machine understands on its own that how I may behave in extreme conditions, it would perform well rather than we controlling it. So that's what my answer to that specific question is. Okay. So controlling such a big machine in extreme conditions is really difficult for us. So let it be the machine which takes the decision, best possible decision in a situation where there's a dilemma to, strike somebody on the road. So with this, I'll stop here, and then we can have a couple of questions uh, if you have any. Thank you so much. Yeah.
Thank you so much, sir. Uh, Dear participants, sir is open for Q&A. If anyone was are ready to ask questions, you can unmute yourself. Sandeep.
Hello, good evening, sir. Hello.
Yeah, hi, good evening. Yeah.
Sir, you just had a topic here when the vehicle is merging into the main line, the vehicle have to stop in the ramp and then it have to enter after getting a green.
You're right.
If the vehicle is stopped there, how can it accelerate to the speed which is moving on the main line?
Yeah, so you give them an enough acceleration length. So
In the ramp, we have to give the distance required for accelerating.
you are absolutely right. Yes. Unless
And
they
one
won't
more
be
thing,
able to merge at higher speeds, right? Because you have to maintain the speed while merging. Because on the
okay,
freeway, speeds are quite high, and you are merging at 20 km/h. There'll be full jam and there'll be shock waves.
okay. Sir, one more thing, in Indian context, expressways, we have a speed limit of 80 to 100,
Mm-hmm.
around 80 to 100 kilometers per hour.
Yeah.
And nowadays, the two-wheeler is also moving with the same 80 to 100 kilometers. What might be the reason of not allowing this vehicle onto that expressways?
Do you want to? I mean, you want to have like see, understand that two-wheelers are the vulnerable road users, right? All of you.
Yes, sir.
So just imagine those vehicles. Two-wheeler is stable when it is moving actually, and unstable when it is stopped. So
Mm.
just imagine if there is there is a